Hey, it's Mrs. Golding. We are in your math packet, page 20, and this is problem number 2. The figure that we have, this geometric figure that we have, there are several questions asked of us. The first question says, describe the shape in your own words. Well, you can describe that however you want to. I thought it looked like a little elf shoe sticking up in the air. Yeah, you can say whatever. My daughter thought it kind of looked like a church. You could say whatever you want. Is there a formula to find the area of this figure? And the answer to that is no, because it's called an irregular or complex figure. And so there's no formula for that figure. And then it says, how can you break the figure into shapes that you can find the area of? And then what are the measurements of those shapes? And can we do it in different ways? And then it says, what numerical expression represents the area of the entire figure? Okay, so let's get started. I am going to have a bigger version here, and I might get rid of my head just so it's not in the way. Okay, now I really like, and I did this on one of our, actually, I think it was the very second, well, it was a very recent problem. I, for some reason, always like this method. I like to add a piece and find the area of the whole and then subtract what I added. Now, it's not the only way to do this problem, but it's one way, right? When I added that piece, that shape right here that I added is actually a trapezoid. Notice that it's a trapezoid. So I can find, first of all, the area of the entire figure, and that's going to be a rectangle. And if I can find a rectangle out of anything, I like to use it because it's easy to find the area, right? So this rectangle measures 6 by 6. Okay, so that's 36 units squared. Okay, that's the area. Now I can find the area of my trapezoid here by doing this. Now you've got a formula that's kind of complex looking, but here's all it is. There's two bases. They are parallel to each other. This is parallel to this, okay? And so I kind of came up with a funny little dance. Then I said, it's the bottom plus the top times the height divided by 2. The bottom plus the top times the height divided by 2. The bottom plus the top times the height divided by 2. Okay, so we're going to say, it doesn't matter. We could call this the bottom. We're going to say that's 4 plus the top, which is 6. That's 10 times the height from here to here must be 3 because this is 6 and half of it's 3, right? So the bottom plus the top is 10 times the height, which is 3, divided by 2, which is 15, right? The bottom plus the top times the height divided by 2. So we got to take 36 and we're going to minus 15. Well, come on now, minus 15. And that's going to give us 21 units squared. Okay, that's the area of this part right here. Okay, now notice we could have totally approached this in different ways. If I'm going to kind of get rid of some of these numbers that I've written here. Remember, the area that we're looking for is 21 units squared, right? What if, rather than adding that other piece, what if I would have divided my shape differently? So I could have divided it several different ways. For some reason, this isn't responding, so we're going to use this down here. Doesn't look like, looks like my computer is not responding. I don't know. It's not happy with me today. Let's try another piece. Oh, I'm a hot mess over here. Let's try this. What if, okay, here's one way. I could find that triangle and add it to that rectangle. I could find that triangle and add it to that trapezoid. I could put this here and find the area of this trapezoid and add it to this rectangle here, right? So there's a whole lot of different ways that I could divide that up. So in my next video, I'll explore some more of those and we'll finish up the problem.